what exactly connects a deep-sea oil rig battling relentless salt water to a highly pressurized chemical heat exchanger handling corrosive acids? I mean, on the surface, they look like entirely different worlds, right? But if you look closely at the invisible backbone of these extreme engineering marvels, you'll find they rely on the exact same foundation. Welcome to today's Explainer, where we're going on a journey into the materials that make modern extreme engineering possible. Today, we're diving into the strict standards that keep our most demanding industries running safely. We are demystifying ASTM A789. And look, this isn't just some random string of letters and numbers. It's the definitive blueprint for manufacturing stainless steel tubing that can actually survive where other metals simply dissolve or crack under pressure. If you've ever wondered how engineers future-proof their designs against literally the harshest environments on Earth, you are definitely in the right place. Okay, let's dive right into this. First, we'll unpack ASTM A789. Then, we'll look at the duplex steel advantage. Third, key engineering specifications, followed by testing and quality control, and finally, real-world applications. Section 1. Unpacking ASTM A789. To really grasp the significance of this material, we need a bit of precision first. ASTM A789 is the standard specification for seamless and welded ferritic/austenitic stainless steel tubing for general service. Yeah, I know, that is quite a mouthful, but let's break it down. Ferritic/austenitic just means we're dealing with duplex stainless steel. This standard is meticulously designed to ensure these tubes offer incredible general corrosion resistance. But more specifically, it targets a little phenomenon called stress corrosion cracking. You know, that nightmare scenario for engineers where a metal just fails catastrophically because it's exposed to high tension and a corrosive environment at the exact same time. Now, before we go any further, let's clear up a really common point of industry confusion: the difference between A789 and A790. Basically, ASTM A789 governs small-size tubing. We're talking about the precise, thinner-walled components you'd find packed tight inside a high-pressure heat exchanger or a boiler. On the flip side, ASTM A790 handles the large-scale, heavy-duty pipe used for massive fluid transportation. So, tubing versus pipe. A789 is all about those precision tubes. Moving on to Section 2, the duplex steel advantage. So what actually makes these tubes so tough? Well, the secret weapon is its dual-phase nature. Duplex stainless steel is defined by a perfect 50-50 split in its microscopic structure. It's roughly 50% austenite and 50% ferrite. Honestly, I like to think of this as a sort of metallurgical superhero team-up. The ferrite phase brings incredibly high yield strength and resistance to that stress corrosion cracking we talked about, while the austenite phase steps in to provide superior general corrosion resistance and makes the metal way easier to weld and form. By combining them, you get a material that is literally stronger than the sum of its parts. But here's the thing, not all duplex is created equal. To push standard duplex into super duplex territory, metallurgists significantly boost the alloy content. Take a look at Super Duplex 2507. It increases the chromium to around 25%, bumps up the nickel, heavily increases the molybdenum up to maybe 5%, and nearly doubles the nitrogen content. In each of these specific elemental additions, they act as a massive multiplier for both strength and chemical resistance. And all that extra chemistry results in this massive number right here, 43 plus. This is the pitting resistance equivalent number, or PREN, for Super Duplex. The PREN basically tells you exactly how well a steel will resist chloride pitting. In other words, how well it survives in hot salt water or nasty corrosive chemicals. For some context, standard Duplex 2205 has a very respectable PREN of around 35. But leaping all the way up to a PRN of 43 or more, that means Super Duplex 2507 can handle highly concentrated, boiling chloride environments without breaking a sweat. Section 3. Key engineering specifications. Now, when manufacturers forge these tubes, the ASTM A789 specification is their ultimate rulebook. It dictates exactly what passes the test and what ends up straight in the scrap heap. This table highlights those strict chemical requirements. Just look at the carbon limits. They are capped at an incredibly low 0.030% maximum. So you might be wondering, why so low? Well, during heat treatment and welding, any excess carbon can bind with chromium, which creates these vulnerable little spots where corrosion can easily take hold. By keeping carbon strictly limited, the standard ensures the tubes maintain their structural integrity all the way from the factory floor to the field. But, of course, high chemistry means absolutely nothing if the metal just snaps or bends under a heavy load. This next table rigorously quantifies mechanical performance, strictly regulating exactly how much the metal can elongate before failing. It also sets these very strict hardness maximums, like a limit of 290 on the Burnell scale for 2205. This is crucial to ensure the tubing remains workable and doesn't just become dangerously brittle out in the field. Which brings us to this staggering figure right here. 450 megapascals. That is the minimum yield strength of standard duplex 2205 tubing. To put that into perspective for a second, that's roughly double the yield strength of your standard austenitic grades, like 304 or 316 stainless steel. For an engineer, this is a total game changer. It means you can use thinner wall tubes to handle the exact same pressures. And what does that do? It drastically reduces the overall weight and cost of your equipment, all without sacrificing a single ounce of safety. Section 4. Testing and quality control. Impressive numbers on paper mean absolutely nothing if a tube fails in the real world, right? So how exactly does A789 guarantee success? By demanding a grueling obstacle course of mandatory quality tests. Every single tube must either pass an eddy current or hydrostatic pressure test just to check for leaks or internal flaws. They undergo tension and hardness tests, and then there are the deformation tests. Seamless tubes are subjected to flaring tests, while welded tubes face flange and reverse flattening tests. So the absolute crucial takeaway here is that every single tube is physically crushed, stretched, and pressurized to prove it can survive extreme mechanical deformation well before it's ever allowed to leave the mill. Section 5. Real-world industrial applications. Okay, so we've seen the chemistry, we know the rules, and we've gone through the testing. Now let's step off the factory floor and into the field. Starting with Duplex 22005, this grade covers about 80% of all duplex applications, and it really shines in intense, moderate chloride environments. We're talking about topside process piping on offshore oil rigs where the salty sea air just completely destroys lesser metals. It's also heavily used in desalination plants to handle highly corrosive brine. You'll find it lining chemical storage tanks and even in pulp and paper mills handling some seriously harsh bleaching lines. It is, without a doubt, the ultimate industrial workhorse. But what happens when the environment becomes completely unforgiving? Well, that's when the upgrade to Super Duplex 2507 becomes totally mandatory. If you're dealing with hot seawater service, basically anything above 25 degrees Celsius, standard duplex will actually start to pit. But 2507? It thrives. It's required for subsea pipelines that are exposed to high pressure and nasty hydrogen sulfide. If you're processing sour gas or working in highly concentrated boiling chloride environments, Super Duplex A789 tubing is truly your only viable line of defense. As industries push further into deeper oceans, hotter processes, and much harsher chemicals, the demands on our materials are only going to increase. ASTM A789 isn't just a dry specification sheet. It's a critical tool for future-proofing global industry. It ensures the invisible backbone of our world holds strong. So I'll leave you with this one final thought. When standard materials fail, how will your engineering designs adapt to the extremes of tomorrow? Thank you so much for joining me on this explainer, and keep innovating out there.